we're gonna have a compound that is made from carbon. It's gonna be made from carbon, hydrogen, and oxygen. And we are going to burn it. Literally, that's what they do. They burn it. We get this compound that has carbon, hydrogen, and oxygen. How do we burn it? We add oxygen to it. And we are going to make, what do we make in a combustion reaction, Hannah?
CO2 and H2O.
Could I balance this?
Yes.
Yeah.
No, because we have no clue what are they. We don't know what are these things. We don't know what these, A, B, and
So we're just trying to find CHO.
we're trying to find how much carbon, hydrogen, and oxygen was in there. A, B, and C. Put C in the other class, doesn't matter. So A, B, and C. We want to know what are those molar ratios. We want to know how many grams we have of each one of those components. Once we know the grams, we'll find the moles, and with the moles, we'll do the divide by the smallest, and we'll find what they really are, right? So let's go ahead and start. They do have to give you some information. The information is, we start with 0.300 grams of this organic unknown. So we can weigh it. We weigh it so we know what was the original mass. Oxygen, there's gonna be way too much, so we won't care. This is my limiting reactant. We won't even have oxygen in any equations. It's too much. Nobody cares. Now the carbon dioxide, they told you that they run it through this instrument that collects the carbon. It has something that will absorb the carbon, and they tell you that you have 0.579 grams of CO2, and you have 0.142 grams of H2O. So they literally ran this compound and they ran it through these two beds, and the carbon dioxide will be collected here and the water will be collected here, and they measure how much they have of that, and that's what they get. So that's all they can give us. What we need to realize in here is that all of the carbon that was here is here, right? So because there is no carbon anywhere else, that means if I know how much carbon is here, how many moles of carbon are here, there should be the same amount of moles of carbon there, right? So I'm gonna do that. And same thing with the hydrogen. If I find out how much hydrogen is in here, I can find the moles. Once I find the moles of hydrogen in this amount, then I can find out how many moles of hydrogen were there. So can you find how many moles of carbon dioxide we have? How would you do that? How can you go from grams to moles?
How to find the molar mass?
Which is 44. So you divide by the molar mass and you find the moles. How many moles do we have? It's 0.579 grams of CO2 times 44 grams, or just divide it per mole of CO2. What is that? You need to put these things away because you're going to use all this space. These calculations, put them to the side or somewhere else, because we're going to be using this space going down. How many moles of CO2 is that?
0.01.
Give me more numbers, at least 3.
0.01.
0.0131 what?
1315.
Okay. Moles of CO2. How many moles of water do I have?
0.142.
Moles of water? Oh yeah, because it's the same, right? 0.142 moles. No. We have 0.142 grams of water. What is the molar mass of water? Yeah.
Oh.
You're doing hydrogen, which is 1 point whatever, but it's not hydrogen. We're looking for hydrogen, but first we need to find the moles of water. So yeah, we're looking for hydrogen, but first we need to go to the moles of water. So what is the amount of moles of water, Hannah?
Do you want me to put it in?
Yeah.
Uh, 0.07. No, 0.0078.
It's 0.0078.
Mm-hmm.
78 what?
8. Yeah.
Moles of water. If I have 1 mole of water, how many moles of hydrogen do I have, Reese? In 1 mole of water, I have how many moles of hydrogen? Yeah? How many moles of oxygen, Colwell? 1, right? In 1 mole of carbon dioxide, Vivian, how many moles of carbon do I have? How many moles of oxygen maximum? 2, right? Does that make sense? So if I have 0.01315 moles of carbon dioxide, how many moles of carbon do I have? Brennan? The same amount, right? Because it's the exact same. So we're gonna say, hey, in here, we're gonna have 0.01315 moles of carbon. It's gonna be the exact same thing because for every mole of carbon dioxide, I have a mole of carbon, right? It's a 1-to-1 ratio between carbon dioxide and carbon, right? And now we're gonna do the same thing for the water. So over here, if we want to, we can go ahead and start writing that for carbon. We have 0.01315 moles of carbon to do my empirical formula, which is my final goal, right? Now for water, if I have 0.00789 moles of water, how many moles of hydrogen do I have, David?
0.01578.
Did you multiply times 2?
Mm-hmm.
Okay. 0.01578 moles of hydrogen. So for every mole of water, I have 2 moles of hydrogen. For every this many, I have double the amount of hydrogen because that's, there are 2 hydrogens in a water. Can anybody think of what is it that I need to do to find the oxygen? Because oxygen, we've got it twice here, in excess here, we have it there, we have the mass, yes. No? No. Redox is for finding the electrons where they're going. I have a sample that I am going to burn. So I have this sample, right? It has carbon, hydrogen, and oxygen, right? It's a whole bunch of sugar. It's carbon, hydrogen, and oxygen. I burn it completely with excess oxygen so that the whole thing becomes carbon dioxide and water. No leftovers, right? No leftovers. I started with, let's say, 10 grams. When I burned it all, I found this many grams of carbon, this many grams of hydrogen. Can I find out how many grams of oxygen did I have? I started with 10 grams. 5 of those were carbon, 2 of those were hydrogen. How many oxygens would I have? I have sugar. I started with 10 grams, right? I found out that of those 10 grams, 5 were carbon and 2 were hydrogen. How many grams of oxygen did I have?
3.
Right? So what do? We found the moles of carbon. Can you find the grams of carbon? So go find the grams of carbon. If you find the grams of carbon and the grams of hydrogen, we should be able to subtract them from the beginning of my sample, and then I'll find my grams of oxygen, right? So do that, and if you want to, I'm gonna give you some time to see if you can finish this problem, because by now, you should be able to have an idea of how to finish it, somewhat.